Welcome to Brain Vision.
So here we're simply for part A going to apply the conservation of energy. And this would give us that the initial potential energy would be equal to the kinetic energy of the center of mass plus the kinetic energy rotational. So this would be giving us mgh. This would be equaling mgl, the length of the incline, times sine of theta, the angle of the incline. And this would be equal to 1/2 mv, the mass times the velocity at the bottom, squared, plus 1/2 times the moment of inertia times the angular velocity at the bottom, squared. And so we can then say that here, mgl sine of theta would be equaling 1/2 mv sub bottom squared plus 1/2 times the moment of inertia of a sphere, 2/5 mr squared. And then this would be multiplied by the velocity at the bottom divided by the radius of the sphere squared. And we finally find that the velocity at the bottom is equaling the square root of 10 gh over 7. And so this is equaling square root of 10 gl sine of theta over 7. And we can solve. So this would be 10 over 7 multiplied by 9.8 meters per second squared multiplied by 10.0 meters, and then times sine of 30 degrees. And so we can say that then the velocity at the bottom is equaling 8.37 meters per second. This would be the linear velocity, and then we can say that the angular velocity would be equaling the velocity at the bottom divided by the radius of the sphere. And we can say that this is equaling 8.367 meters per second divided by 0.254 meters. This is equaling 32.9 radians per second. This would be the angular velocity at the bottom. For part B, they wanted the ratio of the kinetic energy of the center of mass divided by the rotational kinetic energy. This would be equaling 1/2 times m times velocity at the bottom squared divided by 1/2 times the moment of inertia I times the angular velocity at the bottom squared. This is equaling 1/2 mv sub bottom squared divided by 1/2 times 2/5 mr squared multiplied by the velocity at the bottom divided by the radius of the sphere, quantity squared. And we know that this is equaling 5/2. This would be our ratio for part B. And for part C, we can say that the translational speed at the bottom, and so v sub bottom, and the kinetic energy of the center of mass divided by the kinetic energy rotational, this ratio and the velocity at the bottom are independent of radius and mass. And then we can say that the rotational speed, we can say the angular velocity at the bottom is dependent on the radius. That would be our answer for part C. That is the end of the solution. Thank you.